Good morning everyone. My name is Mrudula, working as Assistant Professor in the Department of Electrical and Electronics Engineering in MLR Institute of Technology, Hyderabad. Today I am going to give a lecture about electrical safety devices, which comes under the subject Industrial Electrical Systems. These are the contents today I am going to discuss, like electrical safety practices, different types of practices, the need of the electrical safety devices, and few of the safety devices I am going to discuss, like contactors, isolators, relays, and MPCB. MPCB is Motor Protective Circuit Breaker. So I am going to discuss about few safety devices also. The electrical safety practices. The first one, as we see, to keep away from the water. The electrical equipment should be always away from the water, because water and electricity are like a dangerous combination. So when mixed and can cause the electrocution or serious damage to the whole appliance. So always we should keep away from the water. Second point is unplug electrical safely. Unplug equipment safely. Unplug means when you want to do any kind of maintenance, like unplug appliances before cleaning or adjusting them. Means if you want to do like cleaning process, or if you want to do any kind of modifications, then you have to unplug the whole system and then only you have to do the cleaning part. Next one is install cords properly. All the cords should be installed properly, then only we need to go for the electrical equipments. Next one is avoid overloading outlets. We should avoid the overloading outlets. Most of the outlets can handle around 15 to 20 amperes. Means their capacity is 15 to 20 amperes maximum. And overloading can cause the electrical fire also. So we should always try to avoid the overloading for any electrical equipment. Next one is child-proof outlets. Child-proof outlets. You should use a child-proof, tamper-resistant outlets to restrict the access to the part of the outlet that conveys the electricity. Okay, so tamper-resistant and child-proof should be there. Next point is use lockout and tag-out procedures. This ensures that electrical equipment and systems are de-energized and can be accidentally re-energized during the maintenance or during the repair or any other activities. Seventh point is wear appropriate PPE. Wear appropriate PPE means workers should always wear appropriate PPE to protect themselves from electrical hazards, such as insulated gloves, safety glasses, hard hats, and footwear. So whenever a person is handling any kind of electrical equipment repair work, he should compulsorily have this insulation gloves, safety glasses, hard hats, and footwear to protect himself. The last point is learn electrical safety. Means professional training courses can teach workers about identifying, understanding, and avoiding the electrical hazards. So in order to avoid these electrical hazards, we need to have a trained professionals, and they need to wear the PPE equipments like insulated gloves, safety glasses, hard hats, and footwear. Okay, and the footwear should be a insulator, not a conductor, and accidentally they may get re-energized. So that's why in order to avoid this, they have to wear the PPE compulsorily. They should be child-proof outlets, and they avoid the overloading outlets. Overloading should not be done for a single plug point, and install all the cords properly. All the cords should be installed properly. Unplug equipment safely. While cleaning the process, you should unplug it safely and keep the equipment away from the water. So, all these things are the safety precautions to be taken by the person who is doing the repair or the people who are staying in the house. The need of electrical safety devices. See, here you can see the pictures where to the same plug point we have overloaded it. So this overloading should be avoided, and this picture shows you the equipment like a person who is wearing the PPE kit with gloves, shoes, hat, and to close his ears, hearing protection. This is for hearing protection, and this kit with glasses in order to be protected from the sparks. So this PPE kit should be compulsory available for the person who is coming for doing the repair works, mostly for the high voltage equipments. And this picture, as I said, it is a picture of overloading. Electrical safety devices are important because they protect people and property from electrical accidents. They protect us from electrical accidents. Prevent overloading. We should prevent the overloading, as I said in the previous picture. In this picture, the overloading is done, so this should be avoided. Electrical safety devices protect circuits from excessive current that can cause fires or overheating. We should mitigate the short circuits. These devices interrupt the flow of current during the short circuit, so preventing the damage to the appliances and wiring. The third point is protect against electrocution by cutting off the power supply during the electrical faults. Means like if any fault is occurring in a particular line, we need to cut off that particular point by using the switches or circuit breakers. That is, by using different types of switches or different types of circuit breakers, we should open circuit it in order to protect that particular line and in order to protect the load which is being connected to that particular line. So, safety devices minimizes the risk of electrocution. Safety devices minimizes the risk of electrocution. Next one is ensure compliance. Many electrical safety devices are required here. We require many electrical safety devices here. Few of the electrical safety devices I am going to discuss today. Like, some of them are like contactors, isolators, relays, and MPCB. MPCB is, as I said, motor protective circuit breaker. This is mostly used for protecting the motors. First one is contactors. Here you can see the picture of a contactor. The contactor is an electrically controlled device that repeatedly opens and closes an electrical circuit. They are a type of a relay but are used for high current applications, mostly used for higher current applications. Contactors are compact in size and they can be easily mounted to the field and usually have multiple contacts. They usually have multiple contacts. So, as I said, compact contactors can be repeatedly open as well as close the electrical circuit, and it is also one of the type of a relay which is mostly used for high current applications, and contactors are very compact in size and can be easily mounted to the field, and usually they have multiple contacts which are being connected to it. Here we can see the picture where the contactor is there. Here the contactor coils are being connected and this is the main contact. Here we have 1, 2 and 3 and 4 points here. 3 points are like for R, Y and B and 1 is for neutral. And here you have a reset button, means if like in the transmission, if any kind of problem is there, the contactor will open circuit, and again after rectification of the problem, we can use this reset button to again make the circuit to be closed. Next protective device is isolator. Here you can see the picture of an isolator. An isolator is a switch or control that can completely stop the flow of current, or electricity to a specific location. In electrical engineering, an isolator is a switching device. It is a switching device with visible contacts that can make and break an electrical current in a circuit. Isolators are mostly used, they can completely disconnect a circuit from the electrical supply, which is mainly used for maintenance and for service. They are often used in a main switch. They are often used as a main switch or inside a distribution box. They are mostly used as a main switch and used inside the distribution box. So, this is also a kind of a protective device which can make and break the circuit and which can stop the flow of current if any fault occurs in the line, and it can completely disconnect the circuit in order to protect the device. Here you can see this is the condition of closed circuit. This is the condition of closed circuit. If this particular limb moves with a angle of 90 degrees, then the circuit will be open circuited. So this particular thing is movable, and this is used for closing and opening the circuit. Next type of protector is relay. Next one is relay. Here, relay is an electrically operated switch that opens and closes the circuit, by receiving the electrical signals from the outside sources. That is, based on the signals that is given from the outside, the relay will open and close the circuit. Relays have input terminals for control signals and operating contact terminals. They have multiple contacts in different forms, such as to make contacts or to break contacts. In order to make the contacts and the break contacts, or combination of both. So, as I said, relay is dependent on the signals which is given from the outside sources. Based on the signals given from the outside sources, the circuit can be opened or closed. This is one more protective device, and here you can see the picture of a relay. This is the main source. This is the main source. The main source is being connected, and here you can see a switch which is open circuited. That switch is being connected to the control coil. That is being connected to the control coil, and which is grounded here. The control coil is made up with an iron core. The control coil is made up with an iron core. And here you can see the connection which is given to the load. So, this is the input and this is the output. And this particular part is the signal which is given. The signal from the output source which is given, based on which the relay will open or close the circuit. If the relay is open circuited, the current will not flow through the load. If the relay is in closed condition, the current flows through the load. The next type is MPCB. MPCB is, as I said, motor protective circuit breaker. MPCB is motor protective circuit breaker, is a specialized device that protects the electrical motors, specially designed for the motors from faulty conditions. Specially designed for protecting the motors from faulty conditions, like some of the faulty conditions are short circuits, overloads, and unstable voltage levels. Unstable voltage levels. MPCB are a combination of short circuit and isolation functionality. They have short circuit as well as isolation functionality also of an MCCB. Which is connected to the motor overcurrent protection, which is used mostly for overcurrent protection of an overload relay. When the relay is overloaded, due to which the overcurrent may flow, and from this overcurrent the motor should be protected, and for that case we need to connect an MPCB to a motor. Here you can see the picture where you have here a MCB, that is miniature circuit breaker, and this is MPCB. This is MCB. MCB is given with a supply of 220 volts AC. Here you can see the phase as well as neutral, and from this MCB the connections are given to the MPCB, and from MPCB again the connections are given to the motor. So, the motor is not directly connected to the MCB, it is connected to the main MCB via a MPCB, via a protection device. So, in today's lecture, we have seen different types of protective devices like MPCB, relay, isolator, and contactor, and different safety precautions we need to take, like it should not be overloaded, and proper gloves as well as shoes should be worn during the repairing works or during the maintenance works, and some of the precautionary measures we need to take while the maintenance is going on. Okay, these are the topics today we have discussed. In upcoming videos, like next class, I am going to discuss about topics like residential electrical system and commercial electrical system. Residential as well as commercial electrical system I am going to discuss. Thank you.